plane. Any one plane, if there is no forces, it's called plane stress. If that happens, then this whole thing will get simplified. You will just get a 2 by 2 matrix, not a 3 by 3 matrix. Okay. So far, everything is good. So now let's look at an example. Our problem is the following. I have a plate. The state of stress is given by sigma. Let's pick some numbers so that we make sure we are looking at actual good numbers and not some strange stuff. So I'm going to put some numbers out here. Let's see. I want to pick something. Good. Very good. So I'm going to erase this. And I'm going to put sigma xx equal to minus 46 megapascals. Sigma xy equals 12 megapascals. Sigma xyy, sigma yy is 12 megapascals. Sigma xy is minus 19 megapascals. So what does it look like? This is sigma xx. Remember, sigma xy is minus 19. So sigma xy is like that. Sigma yy is 12. So sigma yy is like that. And then sigma xy is minus. So it is going to point like that. Okay. We don't really care about this. It will be symmetric, but we don't really care about that. That's our state of stress. Hey, wait a minute. I said 6 numbers. How come I gave you only 3? The reason is because the other 3 are 0. We automatically imply that anything that I have not listed here is 0. So sigma yz is 0, sigma xz is 0, sigma zz is 0. That's what it really means. But right now we are just looking at plane stress. Okay. So if I want to find out what's the force on some angle like that, what's the stress, sigma tau equal to how much? We now know the formula, right? So I'm going to write down the formula because we're going to use it. So our formula looks, we'll worry about, let's zoom it back. Okay. Our formula is going to look like this. Sigma equals sigma xx cos squared theta plus sigma yy sin squared theta plus 2 sigma xy sin theta cos theta. Sigma yy minus sigma xx. I'm sorry. Yeah, that's right. See, I also forget sometimes. Sigma yy minus sigma xx sin theta cos theta plus tau x or sigma xy cos squared theta minus sin squared theta. Now comes the nice result. We can simplify this slightly because I can show you that 2 sin theta cos theta, I erased all kinds of things. So let me write this down. Sigma yy minus sigma xx sin theta cos theta plus sigma xy cos squared theta minus sin squared theta. Now we will use some trigonometric formula which says sin theta cos theta is sin 2 theta over 2. Cos squared theta minus sin squared theta is cos squared minus sin squared. So let us see, is cos 2 theta over 2. So plug all these things here, do some fairly simple algebra, and you will get, this means I'll get a much nicer version. Sigma equal to sigma xx plus sigma yy over 2 plus sigma xx minus sigma yy over 2 cos 2 theta plus tau xy sin 2 theta. tau equals sigma negative of sigma xx minus sigma yy over 2 sine 2 theta plus tau xy cos 2 theta. So what happens is I have written everything in double angles. So now it's a fairly easy thing. So let us say if theta equal to 30 degrees, I can compute what's going on, right? Because I just take it, substitute it in here, and I will get for theta equal to 30 degrees. Remember, sigma xx was minus 46. So I'm going to enter all the stuff here, and we can see what we will get. Sigma yy is 12 and sigma xy is minus 19. And I want to do this for all angles theta, and that we know how to do, right? So I'm going to go up here to my nice little, I have all my stuff set up, so I'm going to go up here and I'm going to enter this. So sigma xx was minus 46, sigma yy is 12, sigma xy is minus 19. Okay, so what happens is I have computed, you can see sigma xx plus sigma yy over 2 plus sigma xx minus sigma yy over 2 cos theta blah blah blah. Here are all the numbers for theta equal to 0 to 360. Boom 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 boom, I get a mess, right? And I can plot this fairly easily, which is what I am going to do. So I am going to plot this. So I'm going to take insert, scatter plot. I'm going to do like that. And then because it looks kind of ugly, I'm going to zoom out. And I'm going to do delete. I'm going to redo this thing. Insert, scatter plot. Whoops. Let me do this again. So let's go back up here. And let's say I want to do this. I know there are simpler ways of doing this, but I just want to make sure that we are all on the same page and we know what the heck we are talking about. There you go. And then I'm going to do insert, scatter plot, that. There you go. Okay, I want you to understand a couple of things. Sorry, I gotta go back to home and then I can do all kinds of ink stuff. So by the way, this is the normal stress, and just to make our life nice, I'm gonna go back. Sorry, so I'm gonna go back here and I'm going to go and I'm going to do a different kind of, oh there, we don't want all this linear business, right? Delete. I don't want this linear business. Delete. Okay, so now we have the two graphs. So just to make sure, I want you to understand that this graph, that graph is the tau graph. This is the sigma graph. So okay, so we got the graph. So what's the big deal? Now let's look at our different cases. Okay, suppose it is a ductile material. And our safety criteria is that the shear stress must be less than 25 megapascals. This is called the Tresca criterion. So let's see. Well, if the shear stress must be less than 25, let's see where did we start out. Initially the shear stress was 19, right? Minus 19. It's not going to fail on that face. That's the X face. Remember, on the X face is like that, and the shear stress was minus 19. It's not going to fail there, but you see, tada, 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 tada. Somewhere here, you can see that the shear stress reaches 25. So at what angle? It's about 20, 30, 40, 60. So 20, 40. It's about 45 degrees, maybe 47, 45 degrees. Around 45 degrees, it's going to fail. The maximum is at around 50 degrees, something like that, 52 degrees. When it reaches that, notice that the shear stress is very high, 33. So what will happen is, I can tell you roughly speaking, that if I start raising the stress here gradually, it will fail at this angle, about 50 degrees. I'll fail there. It'll start sliding on the face. On the other hand, so this is how we figure out whether it is safe or not. So we'll clearly say it's not safe, but somewhere in the 40 to 50 degrees from your main axis, it will start shearing when you start applying the loads. Okay. Suppose